Welcome back to Physical Geology, and now I'm going to do the Activity 1.7 on igneous rocks. This will be the identification of the rock samples, and we'll be using, again, we want to use a figure 11 here, the identification table. We want to use this visual estimator. I recommend you cut this out and you'll use it on the rocks, the plutonic rocks, that I'll show you here on the video. And then remember, we need tables 4 and 5, which deal with the descriptions of the plutonic rocks and the volcanic rocks. So I guess it's 3, 4, and 5, and then some volcanic rock terms as well. So you want to use these, and as well, and also going back to the parts of the lab that you've already answered, this may help you out in identifying some of the rocks. We'll be filling out this table, and the sample numbers, there's only 10 samples. We wanted to identify the texture, and then once we get a texture, if we get an aphanitic or volcanic porphyritic texture, then we want to use matrix color to describe the color of the rock. Or if we get a plutonic rock, like a phaneritic texture or pegmatitic texture, then we use that mafic color index to percentage here. And then best we can, I'll point out the minerals present that I want you to identify in the rock. And then you want to name, is it felsic, intermediate, mafic, ultramafic, and then give it a rock name. Again, the rock name will be based on the charts I have up here, tables 3 and 4, right? So you'll either have granite, granodiorite, diorite, gabbro, or peridotite, and then for volcanic rocks, there's a rhyolite, dacite, andesite, or basalt. So we'll go with that there. So let's look at the samples here. So here are the rock samples, and we'll start off with this number 13 here first. So the first thing I notice about sample number 13 is that there are some small mineral phases. And if these are our scale here, some of these larger ones are up to about a millimeter. Most of them are a little bit less than a millimeter. Maybe that's the biggest one's about maybe 2 millimeters. You can see that many of them are less than 1 millimeter. And I don't know if we can make this out. Let's see if I can zoom in a little bit better here. Those minerals are green minerals. You can see this one near the top up here, which is more of a green mineral up there. But the minerals here are not interacting, they're not touching each other. They're separated by a ground mass. So your job is to define what texture would you describe this rock? What texture? And then the next category is are you going to use color index, or are you going to use a matrix color for sample number 13? What green mineral could that be? That green mineral has no cleavage. It has a glassy luster. You can see the flash on it, the glassy luster. And also there's some other little smaller minerals here. These little teeny, they kind of look like this one right here. They kind of look like little rectangles. So there's several of those, and that has prismatic cleavage in 2 directions, and it's a common mineral in this rock here. Then try to determine the compositional group, again based on that either color index or matrix color. And another thing I notice about this, there are a few little vesicles. I'm seeing there are some vesicles in this rock as well. They're small, but there are some void spaces, some vesicles. You can sort of make them out there. And so it is vesicular, but minor vesicular. So you can actually add that also to your textural terms there. So number 13. Here we'll do number 19. You can see right away that I see cleavage flashes of a feldspar minerals there. And so that those pink feldspars, nice cleavage flashes. There's another feldspar here, that white see the white feldspar there, the cleavage? So there's a pink feldspar and a white feldspar. And so your job is to try to determine what those 2 feldspars are. For the texture, I could see minerals growing everywhere. I mean, there's minerals everywhere in this rock. It's packed full of minerals. Then what I want you to do for matrix color or color index, use your estimator. So you want to bring this out and hold it up against a computer to this sample, right? So you want to use your mafic color index and see what percent color index this is. So I want you to make that estimate. And then that'll give you a hint at whether it's felsic, intermediate, or mafic. Now for minerals present, we describe the feldspars and try to estimate a percentage. It seems that there's more of the pink feldspar than the white feldspar. There's some gray areas there. Those gray areas, what mineral could that be? The gray mineral. We talked about those gray minerals. Yeah, so it's vitreous. It's anhedral, that gray mineral, anhedral, which means it probably crystallized late in the crystallization sequence. Then we have these really vitreous, you can see that really vitreous black mineral there. There it is, nice vitreous. So that has basal cleavage, one direction of cleavage, a black mineral with one direction of cleavage. And then there's another area here where it's kind of a splintery mineral back in here, this mineral right in here. And so that's a dark mineral, and that's a prismatic mineral with two directions of cleavage. Black prismatic mineral. In fact, there's another one right there. They make these little sort of fibrous or splintery appearance. All right, so it looks like, and then try to estimate the percentages of both the platy mineral and then that splintery mineral. See if you can make those out to try to give you an estimate. And then do the compositional group and then name this rock. And you'll probably best get the name by using the color index estimator. Now we'll do sample number 18. And the key thing about 18, when we see this one, we don't see any minerals. But I do see a very glassy texture, no mineral. So this one really has, you can use two terms. It's glassy and aphanitic. I don't see any crystals, aphanitic, but I certainly see the glassy. And also note that the curvy nature of the glass there, which means it has a conchoidal fracture. You could really see that conchoidal fracture. Its color is black, but this is an unusual rock in that glass is silica. So this probably has around 70% silica. So it's really high silica, 72% silica. Matrix color may not help you. Obviously, color index is not going to help you. But this is a common volcanic rock that when it erupted, it cooled so fast that no minerals formed. And also it was so viscous that the ions couldn't really move around easily to form minerals. So that's why it's this really glassy rock. So see if you can identify sample number 18. Sample number 40, the first thing I see about sample number 40, it's dark greenish rock, but I see big crystals that with cleavage. And the cleavage there, it's a green mineral with two directions of cleavage at about 90 degrees to each other. So that might help you to identify. And it's a hardness around maybe 5.5 or 6, that mineral. But you can see that it's coarse grained and those minerals are covering the whole rock. In fact, it looks like there's two types of minerals in here. There's the larger green minerals, but then there's that darker mineral here. This area right here, which is a black mineral, probably has two directions of cleavage as well, but this is the one that has more of a splintery appearance. Let's look at the other side here. So yes, again, I see that the green mineral with the two directions of cleavage that's orthogonal, or about 90 degrees, and then a little bit of that black mineral over here. So it looks like this rock is composed of just two minerals. So again, it's coarse grained. There's no olivine in this rock, so that might give you a clue as to naming it, because even though its color index is going to be really high, in order for it to be a mantle or ultramafic rock, it has to have olivine, and this one does not have any olivine. So name this rock here. That's your sample number 40. Sample number 17. Here again we're seeing that classic porphyritic texture, and it's primarily this gray ground mass with these black splintery minerals. Very vitreous. You can see the vitreous shine of these splintery minerals. Yeah, so vitreous. And so they're not biotite mica, but it's a black mineral. And you can see the very vitreous splintery appearance of that mineral. Also, if you can make out here, this should have some plagioclase feldspars, but the feldspars are real. You can see the clear crystals are giving you that cleavage there. Those are plagioclase feldspars. So there's plagioclase, and then there's that dark mineral. So again, determine the texture of this rock, either color index or matrix color. We've looked at a couple minerals already try to figure out the compositional group of this rock, and then name this rock. So here's sample number 12. It's very porous. Lots of little holes in it. It's very lightweight. It's glassy. It's like, imagine like if you had a root beer with lots of foam. This would be like the foam on top of the root beer. So it's very foamy. It's mostly silica glass, so it's going to be 74% silica, so it's very felsic. No minerals. I don't see any minerals. I may see a little bit of banding, which is typical of like a flow structure in a lava. So what will probably help you out is the high silica concentration of this rock to give it a compositional group name. But this is going to be one of those volcanic rock textures. So use a term from the volcanic rock textures to identify sample number 12. Right, now we have sample number 9, texture. Again, what you want to look at here is try and determine if these minerals, you see there's two populations of minerals. There's a pink one with 90-degree cleavage. You see the sharp edges, 90-degree cleavage? And then there's that really vitreous, grayish, clear mineral with no cleavage at all. This kind of has a round nature to that mineral. The pink mineral, try to identify that one, and the clear mineral, try to identify that one as well. Ask yourself, are these minerals in contact with each other, or is there a ground mass separating these minerals? And that'll help you decide what type of texture the rock will have. Once you decide the texture, you either use color index or matrix color. You decide which one to use, and then identify those two minerals I just pointed out, the clear one and then the pink one with 90-degree cleavage, what the compositional group is, and then name this rock. Just to give you an idea of size estimates, most of these are around 1 millimeter or maybe 1.5 to less than 1 millimeter in size. So they're small minerals. So now we're going to look at sample number 51. And this sample, the first thing I want you to notice, there's minerals throughout the rock. So there's no ground mass in this. And it seems like there's only two populations of minerals, or maybe three. I see a vitreous platy mineral with basal cleavage. You can see it's kind of a blackish mineral there with vitreous small. It looks like they're probably 1 to 2 millimeters in size. And then there's that green mineral, green to black, so it's either hornblende or pyroxene, probably hornblende. And then there's that white mineral, which is some sort of feldspar. So looks like there's 3 minerals in this rock. Again, what's the texture of this rock? Use color index to try to determine its composition. And we looked at some of the minerals, try to figure out its compositional group, and then let's look at some of the sizes as well. So you can see some of these minerals are on the order of 4 to 5 millimeters in size. So they're certainly medium grade to coarse grained. Sample number 8 is another volcanic rock, and you can tell it's very light. It has a pink ground mass. It's very ashy, and you can see there are fragments of these white minerals here, which have no cleavage. They have vitreous luster, and then there's pieces of like little rock or something, like you see there. So like a lithic. It might have some there's some biotite mica right there. Again, a very ashy texture. There's a large crystal of quartz up there. So again, texture, matrix color, try to identify a couple of those minerals, do the composition group, and then name this rock, sample number 8. Finally, sample number 2 is another very vesicular rock. Lots of pores, very few to no minerals in this rock, but certainly vesicular. So texture, in this case, you want to, the red might be a confusing, only that there's a lot of iron in this rock. That's why it appears red. It's been heated and rusted to some degree. So it would not be a felsic rock. Then you want to do the composition group and then name this rock, sample number 2.